Hello everyone, welcome to this another video on Java. Now in this particular video, we'll be talking about the stack data structure. What exactly is stack data structure? We'll see how stack data structure, what are the different operations, and we will talk about everything detail that is regarding the stack data in Java. So before we start with the stack, I would like to make sure that you have some idea about the data structure. All these data structures that we use, that is, let's say, stack, English, or maybe view, and other data structures that we use now are all helpful in storing the data in different formats. As I have mentioned you in the linked list video as well, that stack and linked list view, every data has their own relationship among each other. So that's why there are different data structures to capture those relationship, to capture those uh, things among the data that they have. Okay. Similarly, it's the stack data structure. Now, using a particular data structure is it depends upon the data that we are using. It also depends upon what is the problem that we are trying to solve. Basically, a use case for the problem, why we are solving, why we are using that particular data structure. It everything boils down to that. So let's try to understand what exactly is the data structure with a very good analogy of a one-sided pipe. If you have seen a one-sided pipe, or maybe you have seen a closed glass, right? In the glass, let's say you keep some balls, right? If you put some balls in the glass, you can fill the glass with only one side. You put the balls in the glass from only one side, that is from its opening, from its top, right? You can't add the balls from the glass from this bottom, right? Of course you cannot, right? From this bottom we cannot add the balls into the glass. Or if you are entering the water into the glass, you can fill it from the top. Okay, now assume that this is an empty glass or maybe an one-sided pipe, and there is only one opening to fill this particular pipe, and you have certain number of balls that you want to put in. Now if you put the first ball inside this glass, inside this pipe, it will look something like this, where this ball is being stored in the bottom. Let me number this ball as 1. So this number 1 ball has kept at the bottom. Now what I do is I take another ball with number 2 and I put this ball inside this one-sided pipe, or one-sided glass, or a simple glass. Now when I put the ball number 2 here inside this is how the structure finally looks like. The ball number 1 is in the bottom, then its ball number 2 is in the upper position, right? Now the glass can be long as well. The pipe can be a one-sided pipe, can be long enough depending upon its size and number of balls you want. Okay, so there are different sizes of glass that comes, right? There can be small glass, there can be big, there can be a bigger glass as well. So that is not the concern we are here. The main concern and the main observation that you can take from here is that the first ball that you have kept initially, the first ball that you put inside the glass was this ball with the number 1, and it is kept in the bottom, right? It is in the bottom. The next ball that you put inside the glass comes on the top of the first ball, right? So this ball is the second ball that comes above this first ball, right? So it means stack is this is what represents the stack. What is the stack here? This one-sided glass or one-sided pipe. What your stack is. This is how the stack stores the data. The balls are basically the data that you have. Okay, now the data can be numbers, it can be your name, my name, anything it can be, right? And the stack is basically the way we are storing the data. Okay, so that's why stack is basically a linear data structure that follows the last in first out principle. Now this is a very important interview question, and this is a very important concept to understand what exactly is last in out, right? Last in first out is nothing but a concept where you can see the full form: last in first out, LIFO, LIFO, or some people call it first in last out. Again, the same thing. Right? Let me explain you last in first out. See what it means. If you see from this ball's perspective, okay, is this one-sided pipe and ball analogy. The last ball that you have put inside this pipe is the first ball that will come out. That's why the last in, that is the last ball that you have kept inside, or that you have put in, or that you have kept inside this glass or this one-sided pipe, will be the first ball that will come out. First out, FO. So what is the first ball? Now what happened, let's say this is, now this glass is full, this one-sided pipe is full. Now I want to take out the ball. So which ball, you can pause the video and think about it, which ball will come out first? If you have thought on this, obviously the ball number 2 will come out first, okay, and then ball number 1 will come out, right? Because you see, this is a closed jar, right? If you want to take out the ball that is on the top will be removed first, then the ball in the bottom will, right? So the ball with number 2 will come out first, okay. It means this ball number 2 is the last ball that you have inserted, that is last in, correct? And obviously when you start taking out the ball, now this is the first ball that will come out. So that is what it represents, last in first out. So that is the principle of last in first out, that is followed by stack. Now if you have got the idea about the last in first out, let me explain you the first in last out. See, in case of first in last out, what it means is, if you see from the perspective of the ball number 1, okay, the ball number 1 is the first ball that is put in inside. So it is the first ball that is kept inside or put inside the one-sided pipe. And when I start taking out the balls from this glass, from this one-sided pipe, this would be the last ball that will come out. Hello. So it means the object, the data that is kept in the first place in the stack, that is put inside the first place in the stack, will be the last data set, that will be the last data that will come out from the stack, okay. Or you can say the last data that is kept or that is put inside the stack would be the first data that will come out from the stack, if you see from the ball 2 perspective, okay. So there are two different perspectives, both ultimately mean the same thing, both want to represent that there is only one opening in the stack data structure, okay. Whether to put the data inside, whether to keep the data, pull the data outside, okay. There is only one opening in the stack data. Now another important thing, I hope you get the idea about the last in first out or first in last out, and you get the basic idea about what exactly the stack is. Now the very important thing that we want to see is the different operations, different terminologies that are used in the stack data structure. So the first operation, now these things are very obvious guys, okay, and I will always take the analogy and explain you these operations. So the first operation is the push operation, okay. As the name suggests, we will insert a new ball into the open end of the pipe, that's it, okay. You can see here we have performed the push operation when we have pushed this first ball inside the pipe, okay. This is the push operation that we have made. This is the push operation that we have made. We have got this resulted stack. So this is the push operation where we insert a new ball into the open end of the pipe. Pop operation, as the name suggests, we pop, that is we pull out, right? We remove the top ball from the open end, okay. Obviously there would be the top ball that would be removed. So when we started removing the balls, obviously this is the top ball that we have, and this ball will be removed first, okay. So that is what the pop operation does. It removes the top ball from the open end, okay. Only the ball at the top can be removed, and that is the principle of last in first out, okay. The last ball that is what we kept inside the stack will be the ball that is in the top, and that would be the ball that will come out first. So this is the pop operation that we have. Peak operation, now peak is a slight different term and people don't get it initially. That peak operation is nothing but we look at the topmost ball without removing it from the pipe. Let's say I want to know the number of the ball that is in the top, that is 2, right? This number I want to know, right? So looking into the top ball, looking into the topmost ball without removing it from the pipe is what we call as peak operation. Okay, then empty check. Okay, basically we need to check whether this stack is empty or not. See, the stack is empty at this point of time, correct? So we say stack is empty, yes. Is the stack empty at this point? No. Is the stack empty at this point? But if we remove both of these balls in using the pop operation, the stack will become empty, correct? So it only this is stage number one is the place where we can say the stack is empty. Okay, so this operation, that is empty check, will basically check whether there are no balls in the pipe. If there are no balls in the pipe, that's all. That is what it will check. So this is the empty check, this is peak operation, pop operation, push operation. These are the four operations that we need to see in a stack. I hope you get the idea about the operation in the stack. Let's try to see using this GIF. Okay, you can see here the peak always remains in the top, right? Peak always represent the top element. The top element is what the peak will ultimately represent every time. Okay, whether there are one element in the stack, two element, three element, four element. Okay, the stack will represent, peak will represent that. You can see the length of the stack as well. Initially it was 0, then 1, then 2, then 3, then 4, right? So on and so forth until unless I start adding the elements into it. Initially I was doing push operation, that's why this length was increasing. Then I started popping out the elements, the stack operation length is decreasing. Okay, initially the is empty, it was true, now it is false. Then once I start popping elements out, it will become ultimately true again when the length is 0. So whenever the length of the stack comes 0, the empty, we can say that the stack is empty, right? And it has to be. It's a very easy concept. Stack is empty. Okay, in all other cases when the length of the stack is not 0, the stack is not empty. Okay, and how to reduce the length of the stack? We use the pop operation. How to increase the length of the stack, how to increase the number of elements in the stack. Length is basically nothing but number of element, number of data in the stack. Okay, you can see we are doing the push operation, that's why the length is increasing. We are doing the pop operation, the length of the stack will decrease. So yeah, you can see here we have the empty stack. Initially we push the number 5, the data 5 inside the stack. Then we push number 9, that is data 9 in the stack. Then 15. Then what we did, we have done 3 push operations. Now what we do is we start using the pop operation. So the first element that we will pop out, you need to pause the video and think about it. What would be the first element that will come out of the stack if we are at this stage on the program? Okay, what is the first element that will come out? If you have thought of it, yeah, definitely correct. 15 is the first element that will come out of the stack. See, 15 coming out. What we are left with? We are left with 9 and 5. Simple. Okay, we keep on removing, we keep on popping. This operation is called pop, and this operation is called push. Okay, so we keep on popping, the stack will become empty again, like it was in the initial stage. So that is how, and that is what I needed to explain you for the stack. In terms of technology, in terms of the operations we need to see in stack. So that was pretty much all. Now let's talk about the real world application that the stack can perform, and that we can work in the stack, and how the stack works in the real life scenarios. So there is undo and redo functionality in the text editor. You must have seen this undo and redo functionality where you press Ctrl Z and the other command for undo and redo operations in the text editor when you start writing the code, right? So that is something that is performed with the stack, guys. You just press the Ctrl Z and other command for undo and redo, right? But you don't know how behind it is working. So it is working using the stack data structure. The call stack in the programming are very important for tracing the function calls, right? There is a iterative call in the function, right? There is a concept of recursive functions that we will see in Java going forward. Some other video, there is a recursive function that calls there is basically one function calls different functions. So there is a recursive call that will set up. All these recursive calls are managed by stack. Okay, and there is a browser history navigation. Okay, if you want to go back to the browser history, you want to come move forward in the browser history, whatever browser you are using, all of this is managed using stack. So these are some real world scenarios where that plays a very important role, and that is basically in all those places. So yeah, pretty much that was all I needed to cover. These are some of the social media handles that you can follow, and you can follow us on. And yeah, that was pretty much all I needed to cover from this video. Thank you very much for watching this video, and I hope to see you in the next one.